This video is over operations and scientific notation test review. For this problem, we have the number 2.54 times 10 to the second power, and we're going to add that to 8.216 times 10 to the fifth power. Now we're going to start, when we're adding, we're going to start by putting the numbers in standard form. Meaning, we take the decimal, 2.54, we move the decimal point 2 times, 1, 2, and we write our regular number, 254. We're going to do the same thing to 8.216, and for this, we're going to move the decimal 5 times. We fill those blank spots with zeros, and we write it nice and neat, 821600. Now, those are the numbers that we're going to add together. When you're adding your numbers, put the larger number on top. It's easier to add that way. And notice how we line up our numbers. We line them up on that right-hand side. 0 plus 4 is 4, 0 plus 5 is 5, 6 plus 2 is 8. We bring down the 1, the 2, and the 8 because we don't have any numbers left to add. Now we want to take that answer, 821854, and we want to write it in scientific notation, meaning our decimal point starting here at the back, we want to move it back towards the front, meaning we have to go 1, 2, 3, 4, 5 times. And we get a final answer of 8.21854. It's always times 10, and this would be to the fifth power. For number 2, we have the problem 7 times 10 to the third, and we're going to subtract it from 2.3 times 10 to the second. Now, just like before, when we're adding or subtracting, we want to write our numbers in standard form. Meaning, we take our decimal point here at the 7, and we're going to move it 3 times. 1, 2, 3. Filling those blank spots with zeros, and then writing our answer nice and neat. 7,000. We're going to do the same thing to the other number, 2.3. We're going to move this decimal 2 times, so 1, 2, filling that blank spot with a 0, and writing the answer nice and neat, 230. Those are the two numbers that we're going to subtract. The 7,000 goes on top, minus the 230. Notice we line up our zeros over on that right-hand side. 0 minus 0 is 0. We can't do 0 minus 3. It's not possible, so we'd have to borrow. We can't borrow from the 0, so we have to borrow all the way from the 6. The 7 becomes a 6 when we borrow. The 0 becomes a 10. But because we have to borrow it for the other 0, that one becomes a 9, and the first 0 becomes a 10. Now we can subtract. 10 minus 3 is 7, 9 minus 2 is 7, and we can bring the 6 straight down because we don't have any numbers to subtract from it. We take our answer, 6,770, and we want to write it in scientific notation, meaning we take that decimal point and move it to the front 1, 2, 3 times. And we get a final answer of 6.77. You don't have to write the 0. Always times 10 to the third power. For number 3, we have the problem 2.5 times 10 to the third power. And we're going to multiply it by 6.3 times 10 to the fourth power. Now, when we add and subtract, we have to write our numbers in standard form. But we don't have to do that with multiplying and dividing. When we're multiplying, we can just multiply our numbers together. 2.5 times 6.3. 3 times 5 is 15. Put down my 5, carry my 1. 3 times 2 is 6, plus 1 is 7. We are done with the 3, so we add a placeholder value. 6 times 5 is 30. Put down the 0, carry the 3. 6 times 2 is 12, plus 3 is 15. And then we add up our answers. 5 plus 0 is 5, 7 plus 0 is 7, and we can bring down the 5 and the 1 because we don't have any numbers left to add. We have 2 decimal places in our answer, and so we move it 2 decimal places to start. Meaning our answer so far is 15.75. Now, when we're multiplying, we would add our exponents together. Those were the exponent rules that we learned back in August. 3 plus 4 gives us 7. We would combine all that information to write our answer. 15.75, always times 10, into the 7th power. However, this answer is not in scientific notation. Remember, the decimal point always needs to go towards the front. We want it to be 1.5, not 15.75. When we move the decimal up to make it 1.575, we move the exponent up as well. So 7 goes up to an 8. 1.575 times 10 to the 8th would be our final answer. For number 4, we have the problem 9 times 10 to the 5th, and we're going to divide it by 3 times 10 to the 2nd. Remember, with adding and subtracting, we have to write our numbers in standard form. We don't do that with multiplying and dividing. We can simply divide our numbers. 9 divided by 3 is 3. When we're dividing, we subtract our exponents. Those were our exponent skills we learned back in August. Subtracting the exponents, 5 minus 2 gives us 3. We use all of that information to write our answer, 3, and it's always times 10, and then our new exponent is also 3. 3 times 10 to the 3rd power is our final answer. For number 5, we have the problem 8.26 times 10 to the 4th power, and we're going to add it to 6.6 times 10 to the 6th power. We start with our decimal point, and we're going to rewrite the answers in standard form, meaning we're going to move the decimal 4 times. 1, 2, 3, 4. Filling those place values with zeros, and then writing the answer more clearly, 82600. We do the same thing with the 6.6, except for this one, we're going to move the decimal 6 times. 1, 2, 3, 4, 5, 6. Filling in those place values with zeros, and writing the answer nice and neat, 660000. Now we're going to go ahead and add the numbers together. Put the larger number on top, 660000, and we add it to the 82600. Notice how I line up the zeros starting on the right-hand side. When we add them up, 0 plus 0 is 0, 0 plus 0 is 0, 0 plus 6 is 6, 0 plus 2 is 2, 0 plus 8 is 8, and we can bring the 6's straight down because we are not adding anything to those numbers. We're going to take our answer and we're going to rewrite it in scientific notation, meaning we take the decimal point that's at the back and we move it towards the front. We have to go 1, 2, 3, 4, 5, 6 times. And so writing that answer, it becomes 6.6826. We don't write the zeros. It's always times 10, and it's going to be to the 6th power. That would be our final answer. For number 6, we have the problem 3.6 times 10 raised to the 4th power. And we're going to subtract that from 2.6 times 10 to the 3rd power. Just like when we add, we're going to move the decimal point so that our answers are in standard form. For the first one, we're going to move the decimal 4 times. So that means we go 1, 2, 3, 4, filling in those place values with zeros, and writing the answer nice and neat, 36,000. For the other problem, we start with 2.6, and we're going to move the decimal 3 times, 1, 2, 3, filling in those place values with zeros, and writing the answer nice and neat, 2600. Then we set up our subtraction problem. 36,000 goes on top, minus the 2,600 goes on the bottom. Notice how I line up my zeros over on that right-hand side. And then we can subtract. 0 minus 0 is 0. 0 minus 0 is 0. We cannot solve 0 minus 6, so we're going to have to borrow. We borrow from the 6, so that becomes a 5, and the 0 becomes a 10. 10 minus 6 is 4. 5 minus 2 is 3. And we bring the other 3 straight down because we're not subtracting that number. We take our answer, 33,400, and we're going to write it in scientific notation, meaning we take the decimal point that's at the back, we move it towards the front, meaning we go 1, 2, 3, 4 times. Writing our answer, we write it as 3.34. We do not write the extra zeros. Always times 10, and that's to the 4th power. For number 7, we have the problem 4.7 times 10 to the 6th power, and we're going to multiply that by 2 times 10 to the 3rd power. So remember, when we add and subtract, we write our numbers in standard form. We do not do that for multiplying and dividing. We simply multiply our two numbers, 4.7 times 2. 2 times 7 would give us 14, so put down the 4, carry the 1. 4 times 2 is 8, plus 1 is 9. We only have one decimal point in our answer, so we only put 1 in our final answer, 9.4. When we're multiplying, we would add our exponents, as we've already learned. 6 plus 3 would give us 9. We use both pieces of information in order to write our answer. 9.4, always times 10, and that's to the 9th power. For number 8, we have the problem 8.4 times 10 to the 8th divided by 6 times 10 to the 2nd. Just like I mentioned with multiplying, we do not write our answers in standard form. We can go ahead and simply divide. Now, if you are not sure what 8.4 divided by 6 is off the top of your head, which I am not, we set up a long division problem. The 6 goes on the outside, the 8.4 goes on the inside. 6 can go into 8 one time because 6 times 1 is 6, which gets us close to 8. We have 2 left over. Bring down the 4, and we are left with 6 that can go into 24. Six can go into 24 4 times because 6 times 4 is 24. We keep our decimal point straight up in our answer, so we get 1.4. Now, when it comes to our exponents, we're dividing, so we subtract our exponents. 8 minus 2 is 6. And we take those two answers and we write them as our final answer. 1.4 always times 10 to the 6th power. For number 9, we have the problem 6.5 times 10 to the negative 5th. And we're going to add it to 4.7 times 10 to the negative 3rd. When we add and subtract, we want to rewrite our numbers in standard form. Meaning I take the 6.5 and we move the decimal 5 times. 1, 2, 3, 4, 5. Notice I moved it to the front. That is because the 5 is negative. Negative is representative of small numbers, so we want the extra zeros to be in the front. My new answer is 0.000065. We're going to do the same thing to the 4.7, but for this one, we only move the decimal 3 times. 1, 2, 3. Again, we move it towards the front because the 3 is negative. Negative exponents represent small numbers, which means the zeros go in front. 0.0047. Now we're going to set up our problem to add them together. 0.000065 plus 0.0047. Notice how I line up my numbers. The decimal points have to be in a straight line. So when we add them, the 6 and the 5 can be brought straight down because we're not adding anything. 0 plus 7 is 7, 0 plus 4 is 4, and our zeros plus 0 is 0, bringing down that decimal point. We take our answer of 0.004765. We're going to write it in scientific notation, meaning we want the decimal to go behind the first number, 4.7, meaning we have to move 1, 2, 3 times. When we write our final answer, we write it as 4.765. We do not write the extra zeros. It is always times 10, and it's to the negative 3rd power. It's to the 3rd power because we move the decimal 3 times, and it's to the negative 3rd power because the zeros in front mean it's a small number, and small numbers have negative exponents. For number 10, we have the problem 9.7 times 10 to the negative 2nd, and we're going to subtract that from 3.5 times 10 to the negative 2nd. Just like when we add and subtract, we're going to start by moving the decimal point, so that way we can write our answers in standard form. For 9.7, we're going to move the decimal 2 times. So we go 1, 2. Notice we moved it to the front because the exponent is negative. Negative exponents represent small numbers, and small numbers have the zeros in front. Rewriting our answer nice and neat, we get 0.097. We're going to do the same thing for the 3.5. Again, we move the decimal 2 times. 1, 2. Just like before, we move it towards the front because negative exponents are representative of small numbers, and small numbers have the zeros in front. So we get an answer of 0.035. Now we're going to take those numbers and we're going to subtract them. Notice how we line the decimals up in a straight line. 7 minus 5 is going to give us 2. 9 minus 3 gives us 6. 0 minus 0 is 0, and we bring that decimal point straight down. We have an answer of 0.062. But we want to write that answer in scientific notation. We want to take the decimal in the front and we want to put it between the numbers, 6.2. Meaning we have to move it 1, 2 times. To write our answer nice and neat, we write it as 6.2. We don't write the extra zeros. It's always times 10, and it's to the negative 2nd power. It's a 2 because we move the decimal 2 times. And it's negative because the zeros in the front tell us that it's a small number, and small numbers have negative exponents. For number 11, we have the problem 8.7 times 10 to the negative 4th. And we're going to multiply that by 7 times 10 to the negative 5th. When we are multiplying and dividing, we do not write our answers in standard form like we would for adding and subtracting. We can simply multiply our numbers, 8.7 times 7. Now, 7 times 7 is 49, so put down the 9 and carry the 4. 8 times 7 is 56. 56 plus my extra 4 gives me 60. We only have one decimal point in our problem, so we only have one decimal point in our answer, 60.9. Now when it comes to our exponents, we're multiplying, so we would add the exponents together. Negative 4 plus the negative 5 would give us an answer of negative 9. We use all that information to write our answer, 60.9, always times 10 to the negative 9th power. However, this answer is not in scientific notation. Remember, the decimal point always goes towards the front, so it goes between the first numbers, 6 and 0. We rewrite our answer as 6.09, again, always times 10, and our negative 9 moves up to a negative 8. 6.09 times 10 to the negative 8th is our final answer. For number 12, we have the problem 4.6 times 10 to the first power. We're going to divide it by 2 times 10 to the negative 9th power. Just like when we're multiplying, we do not write our answers in standard form. We can simply divide. Now, the 2 goes on the outside, the 4.6 goes on the inside. That first number always goes on the inside. 2 can go into 4 2 times because 2 times 2 is 4. Subtract and we get 0. Bring down the 6. 2 can go into 6 3 times because 2 times 3 is 6. We keep our decimal point in our answer, 2.3. When it comes to our exponents, we're dividing, so we subtract our exponents. 1 minus negative 9. You cannot have a minus and a negative side by side like that, so we change them to addition signs. And 9 plus 1 is going to give us 10. We write our answer using both pieces, 2.3, always times 10, and it's to the 10th power. For number 13, we have the problem 6 times 10 to the negative 4th. And we're going to add it to 3.2. Times 10 to the negative 1st. We always start when we're adding or subtracting by moving our decimal point to write our answer in standard form. So for the 6, we're going to take our decimal point and move it 4 times. 1, 2, 3, 4. Notice we move the decimal towards the front. That's because the exponent is a negative 4. Negative exponents represent small numbers, and small numbers mean the zeros go in the front. We're going to do the same thing to the 3.2, but this time we only are going to move the decimal 1 time. Again, we move it towards the front because negative exponents are representative of small numbers, and small numbers have the decimal in front. Writing those answers nice and neat, we have 0.0006 and 0.32. We're going to take those numbers and we're going to subtract them. We're going to add them. Notice we line our decimal points up in a straight line. We can bring down the 6 and the 0 because we are not adding anything to those numbers. 0 plus 2 is 2, 0 plus 3 is 3, and our decimal point comes in a straight line as well. Our answer of 0.3206 is our standard answer. In order to write it in scientific notation, we want to move the decimal so it goes between the numbers. 3.2. 3.206. We do have to write that 0 because it's in the middle. It's always times 10, and it's to the negative first power. It's a 1 because we only move the decimal one time. And it's negative because negative exponents represent small numbers, and our decimal was in the very, very front, meaning our number is a small number. For number 14, we have the problem 8.76 times 10 to the 7th power, and we're going to subtract that from 9.2 times 10 to the 6th power. When we add and subtract, we want to take that decimal point and move it so that way our answers are in standard form. So we go 1, 2, 3, 4, 5, 6, 7, filling in all of those blank spots with zeros and writing the answer nice and neat. 8, 7, 6, 1, 2, 3, 4, 5 zeros. We do the same thing with the 9.2, but this time we're only going to move the decimal 6 times. 1, 2, 3, 4, 5, 6, filling in those place values with zeros and writing the answer nice and neat. 92 with 1, 2, 3, 4, 5 zeros. We go ahead and line up our numbers in order to subtract them. Notice we line up the zeros starting on that right-hand side. Now 0 minus 0 is going to stay 0. So all of those zeros stay the same. 6 minus 2 is going to give us 4. We cannot do 7 minus 9. It's not possible. So we're going to borrow. The 8 becomes a 7, and the 7 becomes a 17. 17 minus 9 is going to give us 6. 17 minus 9 is going to give us 8, and then we bring down the 7 straight down. We take our answer, 784, with 1, 2, 3, 4, 5 zeros, and we want to move our decimal point back towards the front, meaning we go 1, 2, 3, 4, 5, 6, 7 times, and writing our answer, 7.84. We don't write the extra zeros. Always times 10 and to the 7th power. For number 15, we have the problem 3.4 times 10 to the 5th. And we're going to multiply that by 8 times 10 to the negative 2nd. When we're multiplying and dividing, we do not write our answers in standard form. We simply go straight into the problem solving. 3.4 times 8. 8 times 4 is 32, so put down the 2 and carry the 3. 8 times 3 is 24, plus 3 is 27. There's only one decimal point in our problem, so there's only one decimal point in our answer, 27.2. When we're multiplying, we would add our exponents together. So we would add the 5 plus the negative 2. 5 plus negative 2 is 3. We use all of that information in order to write our answer, 27.2, always times 10, and that's to the 3rd power. However, this answer is not in scientific notation. Remember, we want the decimal point to go towards the front between the first two numbers. We want it to be 2.7. So when we move that decimal point up to make it 2.72, we move the exponent up. 3 goes up to 4. 2.72 times 10 to the 4th. For number 16, we have the problem 9 times 10 to the negative 9th. And we're going to divide that by 3 times 10 to the 3rd. Just like when we multiply and divide, we do not write our numbers in standard form. We can simply divide 9 divided by 3, which is 3. When it comes to our exponents, when we're dividing, we subtract our exponents. So we would subtract the negative 9 minus the 3, which would give us a negative 12. And we use both pieces of information to write our answer. 3, always times 10 to the negative 12th power. Number 17 is a word problem. It talks about a new car that costs 3.49 times 10 to the 4th dollars. And it talks about a new truck that costs 7.86 times 10 to the 3rd dollars. The question is, how much do they cost together? The word together is your key word, and together means add. So we're going to add these numbers together. Just like before, when we have an addition problem, we're going to rewrite our numbers in standard form, meaning we're going to take 3.49 and move the decimal 4 times. 1, 2, 3, 4. Filling in those blank spots with zeros and writing that answer nice and neat for 34,900. We're going to do the same thing with our other decimal, 7.86, but we're going to move the exponent 3 times. 1, 2, 3. Filling in that blank spot with a 0, and rewriting our answer nice and neat for 7,860. Now we can go ahead and line them up and get ready to add. Remember, when we line them up with our zeros at the back. 0 and 0 is 0, 0 and 6 is 6, 9 and 8 is 17, put down the 7, carry the 1, 4 and 7 is 11, plus 1 is 12. Put down the 2, carry the 1. 1 and 3 is 4. We take our answer of 42,760 and we're going to write it in scientific notation. So we take our decimal point that's the back, we move it towards the front and go 1, 2, 3, 4 times and write our answer, 4.276. We do not write the extra zeros. It's always times 10, and that's going to be to the 4th power. For number 18, it's another word problem. It tells us that Stephen ran 2.18 times 10 to the 8th kilometers, and Lucy ran 6.88 times 10 to the 7th kilometers. And the question asks, how much farther did Stephen run than Lucy? Our key word is how much. How much means to subtract, so we're going to subtract our numbers. When we are adding or subtracting, we're going to start by writing our numbers in standard form, meaning we start by moving the decimal 8 times. 1, 2, 3, 4, 5, 6, 7, 8. Filling in all of those blank spots with zeros, and then writing the answer nice and neat. 218. With 1, 2, 3, 4, 5, 6 zeros. We're going to do the same thing with 6.88, except we're going to move that decimal 7 times. 1, 2, 3, 4, 5, 6, 7. Again, filling in all those blank spots with zeros and writing our answer nice and neat. 688 with 1, 2, 3, 4, 5 zeros. We can go ahead and set up our subtraction problem. The 218 and 6 zeros goes on top, and we're subtracting the 688 with the 5 zeros on the bottom. Notice we line up our zeros starting on that right-hand side to subtract. All of the zeros can be brought down because 0 minus 0 is 0. We cannot do 0 minus 8, so we're going to borrow. The 8 becomes a 7 and the 0 becomes a 10. 10 minus 8 is 2. We cannot do 7 minus 8, so again we're going to borrow. The 1 becomes a 0 and the 7 becomes a 17. 17 minus 8 is going to give us 9. We cannot do 0 minus 6, so again we're going to borrow. 2 becomes a 1 and the 0 becomes a 10. 10 minus 6 is 4, and we can bring the 1 straight down. We get an answer of 14,920 with 4 extra zeros at the end. We want to move our decimal point from the back towards the front between the first 2 numbers, meaning we move our decimal point 1, 2, 3, 4, 5, 6, 7, 8 times. And we write our answer as 1.492. We do not write the extra zeros. It is always times 10, and it's going to be to the 8th power because that's how many times we move the decimal point. For number 19, the word problem asks 3.2 times 10 to the 8th is how many times greater than 2 times 10 to the 2nd? Our key word is how many times. How many times is a division problem. So we're going to divide our two numbers. We start by dividing 2 into 3.2. 2 can go into 3 one time. Subtract and we get 1. Bring down the 2. 2 can go into 12 6 times. And keep your decimal point in your answer. When we're dividing, we subtract our exponents. So we would subtract 8 minus 2, which is 6. And use all of that information to write our final answer. 1.6 times 10 to the 6th power. For our last problem, it tells us that there are 5.256 times 10 to the 5th minutes in a year, and there are 6 times 10 to the 1st seconds in a minute. Our question is how many seconds are in a year? So when we are going from something small, like seconds, and changing it into years, something large, that's a multiplication problem. So we're going to start by multiplying our numbers, 5.256 times our other number, 6. 6 times 6 is 36. Put down the 6, carry the 3. 6 times 5 is 30, plus the 3 is 33. Put down the 3, carry the 3. 6 times 2 is 12. 12 plus 3 is 15. Put down the 5, carry the 1. 6 times 5 is 30, plus 1 is 31. And keep your decimal point in your answer, 31.536. When we are multiplying, we would add our two exponents together. 5 plus 1 is going to give us 6. And we would use both pieces of information to write our answer, 31.536 times 10 to the 6th power. However, this answer is not in scientific notation. Remember, the decimal point needs to go between the first two numbers, 3.1. So when we move the decimal point up to make it 3.1536, we have to move the exponent up as well. 6 moves up to a 7. 3.1536 times 10 to the 7th is our final answer.